Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 6 Chemistry students. How are you? Welcome back to this other lesson. Alan is my name, and we are still on topic of chemical kinetics, Unit 14, which is about rate laws and their measurements. Now heading into lesson 3, which is on determining the order of a reaction. Well, I hope you're safe and you have your calculators. You really need to have one. In this lesson, we shall do a lot of calculations. So, let's take a quick recap on the last lesson to bring you to speed on what we are going to look at. We ended on order of a reaction and the rate equation. Basically, we looked at how to come up with that rate law or the rate equation, and we said rate law is about seeing how the rate of reaction varies with changing concentration. So from this rate law, this small a is the order of reaction as the concentration of A changes, then B is the order of reaction as concentration of B changes. So when you add A and B gives you the overall order. That is what we looked at. And we ended on the characteristics of the order of a reaction, whereby we said it can be a whole number. It can be 0, 1, 2, or a fraction. And it is not depending on how you balance this equation. Maybe say this is 1, 1, so A will be 1 or B will be 1. No, it is experimentally determined. It is coming as a result of experimental analysis. So, in today's work, we shall be looking at what exactly A and B, what do they mean and where do they come from? Remember, we're saying they are determined experimentally. And what do they exactly make this rate equation imply? If someone who has no idea on chemistry comes here and sees that rate equation, we want that person to understand what is exactly happening. And so that is today's lesson. Determining order of a reaction in any chemical reaction. So, again, the focus will be on the method of determining, which is initial concentration and initial rate method. Then we perform calculations. This takes me to orders. First order, second order, and zero order. So what are they, what we are to look at? Please pay close attention and participate in the lesson. So we have one objective, which is you should perform correctly all the calculations involving rate equation and orders of a reaction. So, first order, second order, zero order. What are they? There we are, order of a reaction. Normally, when you look at this rate law, there are many forms or many ways this rate law can be written. You can include reactant C, include reactant B, include whichever reactants you have, indicating if you have 4 reactants, they will all be included. If you have 1, it will be included. So that's why we're saying there are different forms where you can come up with this rate law. But mostly in the chemical reactions, most of the chemical reactions go through 3 rate laws or 3 forms. What are they? Those are the forms. Zero order, first order, second order. I think at this moment we are coming to understand what this A implies and what this B implies. Look at this. Our general reaction. We still have A reacting with B. Don't mind about the product. The issue of the product should not concern you at the moment. All we want is, are these two reacting? Yes, if they are reacting, what is the speed at which they are reacting to form the product. The kind of product is not part of the concern. So, again, remember the rate rho or the rate equation is relating the concentration of the reactant in regard to the rate of a reaction. So in this case, we are going to keep B constant and see how, if we change the concentration of A, will affect the rate of reaction. So if we change the concentration of A and the reaction doesn't change, or the rate remains stable, then that is a zero order. In other words, this power, which we would call A, becomes zero, because you know any number power zero is always 1. So indicating the concentration the rate remains constant even when you change concentration. And so we have a 2, we have a 3. For first order is when you double the concentration, then the rate doubles. In other words, the rate is directly proportional to the concentration. Then for the second order is when you double the concentration, the rate increases by a factor of 4. That is what we mean by the square, or A squared. So these are the 3 general rate laws that most chemical reactions conform to. It's either a zero order, a first order, or a second order. So this is the chemical illustration of what we say it is a first order, second order, and third order. I believe so far you are already talking in terms of the chemical language. You don't need to say it is a first order. Just say rate is directly proportional to the square of the reactant. In that way, the scientist will understand. That is why we call the science language. Okay, so how do we basically determine the order of a reaction? How do we determine whether it is 0, it is 1, it is 2? Any idea? How do we come up with a value to be 0 or to be 1 or what? Remember what we said, what we are going to look at? We said we are going to look at the initial concentration, initial rate method. And that is it now. Initial concentration, initial rate method, which we normally call discontinuous experimentation. So in this approach, what happens is you get your reactants, let me call it A and B, get the concentration of one reactant and maintain the concentration of another reactant. So if you're having, again, A and B, keep A constant, vary B, or keep B constant, vary the concentration of A. So start with maybe 1 mole per decimeter cube, that is the concentration at the start. Cut out the first experimentation, or cut out the reaction. Let it go through. So when it is complete, get another set of the solution, or get another amount of that reactant A. Again, cut out the experimentation. But in this case, change the amounts of the concentrations. That's what we mean. As you do change the amount of concentrations, then the rate will also likely to change, depending on whether the reaction is first order, second order, or third order, as we are coming to see. So repeat as many times that experimentation to see how the change in concentration affects the rate. So that is the whole idea of the discontinuous experiment. Start one experiment on a side, do another on a side, and determine the rates. So this is what happens, as I gave you the example of A and B. So if you are keeping concentration of B constant, then in our rate expression is not going to be involved because it is not affecting the rate in that way. The rate is only depending on the concentration of A, since you've maintained it constant. So if you double the concentration of A and the rate is not affected, that is a 0. I had already said about it. Because any number power 0 is always 1. So that indicates rate is directly or is equal to a constant. Suppose you double and the effect and the rate also doubles. What happens? That becomes the first order. We put power 1. And lastly, the second order, whereby the rate increases by a factor of 4. So that is how it is obtained. As again, I need to mention this. To either call it 1 or 2 or 0, it has to be from the experimental values. You can't look at the reaction and say this is going to have a first order rate or a second order or a 0 order. No, it has to be experimentally determined. So can we present this understanding on a graph? Can we present this understanding, this rate to rate versus concentration on the graph and find how these 3 orders of reaction vary? What do you think? If it is you plotting, what would be the kind of graphs that you'd obtained? Using your mathematical and physics knowledge, what do you think would be obtained? Rate versus concentration. I'm giving you a minute to think through. Plot this, and this. What would be the possible curves? Rate on the y-axis, concentration on the x-axis. That is what you would get. Is it what you had in your head or in your mind? So basically, this is what we mean. Rate remains constant irrespective of change in concentration. That is 0 order. Increase concentration, increase the rate, because these are directly proportional. Whereas increased concentration, the rate increases by a factor of 4, meaning the gradient is just proportional to concentration. These two bring the whole understanding very, very clearly. Okay, so that is it in terms of finding the order of a reaction. Of course, as usual, for such a kind of a case comes out based with a practice question. You understand right now we can't go to the lab to have this carried with you, so the experiment is carried out, then we are using the data. So we're having the data for this question. Take a minute and read through the question. Because I want us to do this question together. I don't want to leave you behind. Remember, I told you, get your calculator and be ready. So, what information do we have based on what we've just looked at? We have the equation. Azomethane decomposes to give ethane and nitrogen, as you see. We have the data for the first experiment, whereby they had the initial concentration and they determined the initial rate. They carried out the second experiment with the concentration being doubled. Then they noted the rate, also the rate kind of doubled. So our question is, we are to determine the order of reaction with respect to azomethane, then write the rate equation. Remember, from our rate of reaction, we need orders, the order of a reaction, so indicating we must get the order from there. So let's go through it together, hoping that you've read through and you understand what is happening. One, the orders of a reaction. So how do we come up with the order of a reaction? First, we must take an assumption and say, let the order of a reaction for this reactant, since it is a single reactant, be Y. So we write the rate expression, rate equaling to a constant K, the concentration of this reactant raised to the power Y, which is our order. Remember, we're not knowing Y. It has to be got from the values of the experiment, which we have here. So that is the first step. The second step is, can we substitute the values we have for rate and concentration to get Y? Yes. So using experiment 1, we have rate here, we have concentration. K is a constant, and since this is at the same temperature, then it will apply to all these experiments, all the experimental values. So that is our first part. Am I moving with you? I hope yes. And if I'm leaving you behind, please try to catch up as faster before I go to the next step. From here, you can even predict the next step. The next step would be doing the same thing to experiment 2. So we have in equation 1, that is the values from experiment 1, equation 2, the values from experiment 2. So how can we get Y using your math knowledge? You have this and this. Similar values, the difference now is the concentrations. So indicating if we can divide equation 2 to divide it by equation 1, we can get Y, can't we? This is what we would get. Using your calculator, this directly gives us a 2, and this gives us a 2. But this value is having the power Y. Here, we are having a 2. Applying your math, any number power 1 is always that number, meaning 2 without any letter on top here means it has a 1 on top, because any number power 1 is always that number. 2 power 1 is 2. So if you write it this way, it's directly similar to this. PCB students, you have sub-math, I know, so this is not new to you. So from this, what do we conclude with? Rate, Y becomes 1, and if we have 1 as Y, which was the order of a reaction, that means the reaction is first order. What do we mean by the first order? Rate is directly proportional to concentration, meaning double the concentration, the rate will also double. Reduce the concentration by a half, the rate also reduces by that specific amount. So that is the aspect. When we say it is a first order, a second order, we are meaning in terms of how rate relates to changes in concentration. So that was the first part. Second is calculate the rate coefficient. I really need to leave that. You have rate equation or rate law. You're having table of values. You've already gotten the order of a reaction. Substitute and get coefficient. Do I need to go through that? Well. Just for the sake of being the first exercise. So, simply you have your table. What you just is select any experiment and use values for that experiment. You can select experiment 1, you have the initial concentration and the initial rate, then you feed it in the rate equation directly, you get the answer. So that is the rate constant. Substitute and get the value. Any question on that? If you have any question, share it with your friend. Now, let's also practice another question. This is kind of different from what we looked at, but same principles. Same principle, but just simply kind of different. Take a minute to read through it. Look at those values and information highlighted. I want you to come up with the answer. I will not give you my answer before I get to see that you're done doing that. Yes? So, you have the reaction, you have the information. As again, the order of a reaction can only be obtained from the experiment. That's why any information you're going to be using about rate laws, it has to be connected to experiment. It has to be data from experiment. As you see, results from the experiment show that the rate of production is directly proportional to the concentration of both this and this. We have two reactants. So they're saying the rate is directly proportional to these two. From the quick understanding of what we've been covering, you can pick up the order of reaction just right here. But let's see what happens. So we've been given the value of K. We had to find the rate law, or to write the rate law using K value, and deduce the overall order of a reaction. So going with me, the order of reaction, we must first assume, because we don't have it, the order of reaction with respect to this first reactant to be a certain value. Call it A, call it B, whichever value or whichever numerator you want to use, just use that. So let's call it A, then potassium iodide, we call it B. These are for my choice. Select yours, it's okay. So when we have this, then we must go ahead and write the rate law, which would be a constant, then the concentration of this reactant and this reactant. All these two reactants are affecting the rate of a reaction. So we must include them in the rate law. So from there, we get the order. How do we get the order? We already know that the rate is directly proportional to both this reactant and this reactant. So by being directly proportional, that means it is the first order. Increase or double the concentration, the rate will also double. So it becomes the first order. So A becomes 1, B becomes 1. Can we just substitute it? Substitute the value of K which you have and the orders that you've obtained. And this becomes the rate law for the reaction. As simple as that. Understanding what is happening. Remember, these values, these numerical values, 1, 2, and 0, they imply how rate changes with concentration. Then part B, deduce the overall order for the reaction. Overall order, you simply add the orders involved in that reaction. You simply add A and B to get you 2. You add this value and this to get you 2. So the overall order is 2. So basically that is it. What you need to know is the order of a reaction is the power in which the concentration of a reactant is raised to in the rate law. What does that imply? It gives us the understanding on how the rate changes when the concentration of that reactant changes. As simple. This is mathematical. Bring words to numbers, to the formula, and that is it. So thanks for being part of the lesson, and as usual, I can't leave without leaving you with the exercise to test you on whether you've understood what we've covered. That is the exercise. Exercise 3. Again, like how we do it, go and try. Try, attempt, so as when we come and go through the exercise, you're not blank. Try the exercise first. When you get any problem, then it can be resolved when we come back. as we correct the exercise. Thank you for being part of the lesson. Alan is my name again, and I'm happy to still be interacting with you. Please stay safe. I want to see you in the next lesson as we go through that exercise too. Bye.